I'd like to welcome you all to the AMREP precinct, where we are about to unashamedly expose you to an hour and a half of propaganda of the highest quality to try and convince you all that your honours years should be spent at this campus rather than at Clayton or elsewhere. My name is Steve Jane. I'm head of the Central Clinical School, which is one of the two schools on this precinct, the School of Public Health and Preventative Medicine, headed by John McNeil being the other. But a number of years ago, we decided that we should have a unified forum for our honours night. And although I head that, standing here as the head of the Central School, I represent our partners on the precinct, which includes the Baker Institute for Cardiovascular and Diabetic Disease, the Burn-In Institute for Infectious Diseases, and of course the Alfred Hospital Clinical Service. And essentially the four of these form the four research pillars at this precinct, and there are opportunities in any of the four to do additional studies with honours or higher degree research in PhDs. So the program, I'm going to give you a welcome and introduction. I'm then going to pass over to Professor Sharon Lewin here, who's Professor Director of Infectious Diseases at the Alfred Hospital, one of Australia's foremost clinician scientists, particularly in the area of HIV. In fact, Sharon is chairing the World HIV Congress in Melbourne next year and has routinely been spotted with Bill Gates and Bill Clinton of late. So she has incredible international pedigree, and she will talk about clinical research opportunities. Next to her is David Curtis, who again is a tremendous clinician scientist, a haematologist, who will talk about more basic biology, which is certainly on offer here, as well as the clinical opportunities. And then we're going to have some words from Jodie Abramovitch, who's a PhD student, talking about her experience of honours on the precinct, and Associate Professor Mark Wright, who's the Honours Coordinator here, who will give you facts and figures and everything that you need to know about potentially doing honours. After this, we have displays outside. All of the partners and many of the individual laboratories have got representatives here who are postdocs, principal investigators, honours students, PhD students. There's a whole range of people you can talk to about the experience of working on the precinct. And then there are some lab tours after that you can go and actually look at the geographical circumstances that you'd be located in. There's some beautiful laboratories on the precinct with views over Faulkner Park and so on. So if the science is boring, there's always something to look at out the window. And finally, we're having some pizza and refreshments to round off the night. So I do welcome you all. I know a lot of you have made the trip from Clayton and elsewhere. We're grateful, and we certainly hope to make the experience something that gives you something to think about when you're choosing where you're going to work next year. So I think the real point of difference that I want to emphasise of coming to this precinct is that this really is a translational research precinct. Most of the lead investigators here are clinicians or have strong collaborative links with clinicians, and that means that the interface between their science and a patient is much, much closer. The distance is very short. And really, I think everybody thinks about their science here in terms of what impact it can make to patient situations. How can it improve diagnosis? How can it alter management? How can it improve the human condition? And I think that is a really important point of difference between Clayton, which does magnificent science, but probably lacks that ability to have the direct translational aspects, which there's no question comes from sheer proximity. We sit here, the Alfred Hospital sits right there, but also the type of people who lead the research effort here, people like Sharon and David, who are clinicians by nature. So I think that is a real point of difference, and even the departments, and there are many of them that are not headed by clinicians, have a strong clinical focus and clinical links at the hospital. So I think this really, one of the compelling reasons that you would consider here is that you think that translational research, the ability to make a difference in human health, is one of your major drivers. That is a good reason to come here, I think. So, as I said a number of years ago, we decided to make this night really as a shop front, rather than having every individual institute have their own night, their own speakers and so on. Really, this is Myers Windows. You can come here and you can get an entree into cardiovascular medicine, into diabetes, cancer, haematology, infectious diseases, immunology, gastroenterology, public health, and so on. It's all available to you. It's all outside. We're just going to give you some generic overviews without focusing on any individual areas at this seminar, but afterwards you'll have the opportunity to delve into the areas that you may be interested in the rooms that are outside. As I said, the advantages here are the proximity to the hospital, the affiliation with patients, the links with clinicians, and all of these I think are certainly dear to our hearts, and we think that it's an emerging theme for young scientists, that the esoteria of science is really gone these days. It's demanded by the NHMRC and the other funding organisations that our work translates into outcomes, and I think students are really looking forward to that. Many of you go into science with a view to try and help humanity, and I think this is certainly a place that gives you the opportunity to do that. We love you to come and do honours. We love it even more if you stay on to do PhDs, and so certainly we'll be discussing the option of looking at this as a career path for you. And I think that's another important thing to think about, that when you look ahead to what your career opportunities might be in science, that the exposure to translational research is a real bonus for you. A lot of you may not go on to do PhDs, many of you might decide to go into industry, education, media, and the ability to interface with research and medicine is very important, and I think you will get that grounding here that you won't get in other areas. So one of the huge selling points for us is the environment. I don't need to sell you that apart from these photos. Magnificent Albert Park Lake, Paran Market, Chapel Street, sensational shopping. And I always like to say, I sound like a real estate agent, I love to contrast with Clayton. And this is really what you get out of Clayton. You get Dandenong Road with trucks, warehouses and other things. So I think if you just compare and contrast those two slides alone, there are compelling reasons to come to the AMREP precinct, in addition to the science that I think I've already exposed you to. One of the concerns that people have is that they have to leave the mothership at Clayton. It's a bit of a concern. They worry that it's going to be an isolated procedure at AMREP, but I can tell you that our honours numbers are increasing year by year. And I think this is the mosh pit last year of the honours celebration with about 10,000 honours students on the precinct. So there's no shortage of people to work with, to talk about your research, to socialise with, to collaborate with. We really have a vibrant undergraduate program here now for honours students. So I think that idea of being separated from Clayton is really no longer a worry, and we have great pastoral care and oversight of our honours programs here. So I've probably babbled on enough. I think with that introduction, I'll pass you over now to Professor Sharon Lewin, as I said, one of Australia's foremost clinician researchers in the area of infectious diseases, and she's going to give you the clinical perspective about research at AMREP. Thanks, Sharon.
Great. Thanks, Steve, and welcome to all of you. Great to see so many people here interested to coming to AMREP. I'm going to talk about clinical research, and I thought I'd just start with getting an idea of how many people here have a background as medical students or doing medicine. Okay, so most of you probably haven't had much contact with patients or with clinical research, so I just thought I'd just quickly give you a sense of what clinical research really means. It can be a translational project, and Steve sort of started with talking about what that is and how that's such a strong strength of the precinct. So what do we mean by translational medicine? It means different things to different people. It essentially means working at the interface between patient care and the laboratory. So it can mean moving things from the laboratory into clinical trials or patient care, and vice versa, taking questions or observations from the patients into the laboratory. So generally a translational project might mean using samples from a patient to answer a fundamental question in the lab. And my experience is that students really love this because they can actually see the direct relevance of why they're studying a very, very detailed pathway or mechanism in the laboratory that's directly related to the patient's samples that they're studying. It can be observational studies. Clinical research can mean just observing patients to better understand the natural history of disease in both individuals or populations, and that's the interface really perhaps between our school and the School of Public Health, but I think observations in populations happens in both, or to better understand an interventional treatment for patients. Finally, clinical research can be interventional, so to understand the impact of a new drug or a new device or an intervention that might be behavioural or educational, and you ask the question, what's the impact, how things change before and after the intervention. So sort of the gold standard in clinical research is a randomised clinical trial. This is just an example of a clinical trial that's been done by a PhD student I'm co-supervising, Janine Trevelyan, asking whether using an anti-cholesterol agent can change inflammation in HIV. And I just show this as an example. It's a beautiful way to ask a question, to randomise a patient to getting placebo or getting an intervention. You have a clinical outcome that may take a long time. So Janine's with us for several years, so her study is going over several years. And within that larger randomised clinical trial, there might be sub-studies that are asking a biological question. So you might have the opportunity to work on a big randomised clinical trial, but asking perhaps a smaller, more manageable question. So Janine's looking at the effects on immune function inflammation, as well as looking at a clinical outcome. This is a very, very nice environment to ask a clinical question. So look out for randomised clinical trials. It's often the best way to answer a question around an intervention. So why do a clinical research project? What are some of the advantages or things you might learn? I think you get hands-on experience of how a well-designed question can have a real impact or change health outcomes. And often the lead time between your research and an impact on health outcomes is not that long, which makes clinical research extremely satisfying. I think it's an opportunity for acquiring really diverse skills, not just in scientific thinking, developing a hypothesis, designing, asking the right question and designing a good study. There's a whole lot of other related skills that you will learn that will be relevant to many disciplines. So how to do ethics applications. You might have the opportunity to actually have direct patient contact depending on what research you're doing, perhaps in interviewing patients. Certainly here, given the crossover between clinical research and basic research, you might be processing human samples. There's a whole lot of skills that go along with that. And then, of course, statistics and data analysis, which is a feature of all research, but can be slightly more complex in clinical research because you might be handling very big data sets. You get the opportunity to work in a large team, and I think that's really enjoyable for students who can often feel isolated working on a small project. The experiments will always work. You may not get a positive answer, but I don't think you're ever going to be tearing your hair out because something just doesn't work, it doesn't work, which is often a problem in laboratory research. And it could even take you to some interesting places. We, for example, have projects. On the left you can see a project we've been doing in Durban in South Africa. We had a PhD student looking at HIV and Cryptococcus. We've had honours students and PhD students working in Bangkok. We've had a long-standing collaboration looking at HIV and hepatitis B. We have other collaborations with centres in San Francisco and Chicago and the UK and France, and I've tried and find an opportunity if the student wants it, and I think many other lab heads would also have those sort of links internationally. May not mean spending the whole time away, but certainly we're very flexible about you spending several months, even in an honours year, but certainly within a PhD in another lab. I try and do that a lot for my students, and they all love it and learn a lot. So what to look for when you're thinking about maybe a clinical research project might be of interest. It's really worth going into an established team with a strong record of high quality research. It means you'll be up and running quicker and you'll get an outcome much quicker, and there are many teams that meet those criteria based here at AMREP. I would just advise you to avoid retrospective studies, meaning sort of looking back at stored data. It's much more exciting and you get a much cleaner answer if you start afresh with a prospective, observational or perhaps randomised study, and it's worth the time investment to set that up, certainly in a PhD. You need excellent statistical support both in designing the study and also in analysis, and we have that both within the Central Clinical School and also given the strengths of the School of Public Health, which has outstanding epidemiology and statistical support. And make sure that you're going to be asking an important question that's clinically relevant, and I think you'll get that here because people know what the issues are on the wards or in the clinic because they're doing both all the time. important, make sure that the project's feasible, achievable in the time frame, and that you can see really a path towards an impact, perhaps, might be many years, but a long-term impact on patient outcome. And I'll hand over now to Associate Professor David Curtis, Head of Haematology Research here at AMREC. Thanks very much.
Thanks, Sharon. I was just saying to Steve that if clinical research is, you always get an answer, I guess it's a bit like 2020 cricket, as where laboratory research might be a bit like test cricket. It may not always work, but when it does, it's a great experience. And I think that's probably the one message that I would give to you is the great joy of doing laboratory research. I'm a clinician, but I spend probably 70% of my time in the laboratory because of that great joy that doesn't happen every day, but when it does happen, it's a fantastic experience. So to illustrate that point, I just wanted to tell you a little story. And it began about 30 years ago. This is a histological section of follicular lymphoma. So this is a type of lymphoma, a B-cell lymphoma, where there's rapid growth of B cells. And at about that time, cytogenetics had been sort of revolutionised, and a reciprocal translocation was discovered between chromosome 18, where there's BCL2, which is a gene, B-cell lymphoma number 2, was identified, and it was shifted onto chromosome 14, where there's the immunoglobulin heavy chain. So now you had constitutive expression of this gene BCL2, or the protein BCL2, in these follicular lymphomas. So about 90% of follicular lymphomas have this protein. And really nobody knew what BCL2 was doing, how was it causing follicular lymphoma. So this is a story of a PhD student. He started as an honours, but it became a PhD. And to try and work out what BCL2 was doing, you can't really, clinical-based research is impossible to do that, so you have to do laboratory-based research. And so what he did was, this is about 25 years ago, was to take a cell line. This was a growth factor dependent cell line, and he put in a control vector which didn't express anything, or he generated a cell line that it was overexpressing this gene BCL2 to try and work out what was going on. And what they thought was going to happen was that this would make the cells grow really fast, because this is from a lymphoma, lots of cells, and it should be make them proliferate more. But despite about 6 months of work, he couldn't find anything wrong with these cells. They grew the same, they just looked the same, there was no difference in the appearance of them. And he set up one more experiment. He thought, we'll try this. And so he set up this growth curve, and here it is here, starting here. And this was on a Wednesday. And as I mentioned here, this is a growth factor dependent cell line, so you need to add growth factors for them to survive. And silly PhD student forgot to add the growth factor. And he was measuring the growth of these cells to see if they were growing more. And sure enough, without adding the growth factor, the cells started to die. So here's the growth curves. And it was Friday, and the pub called. So this was a tradition of the laboratories that they had to go to the pub. And they didn't actually go to the pub for 40 days. He just went for the weekend. And instead of throwing the cells out, because he thought, oh shoot, I forgot to put the growth factor in. So he went to the pub anyway. And he came back on the Monday, and he went to the incubator and he thought, oh, I'd better throw those cells out. I forgot to put the growth factor in. The experiment hasn't worked. He opened the incubator, and he looked inside, and he saw the 2 plates. There was one plate which had the control cells in them. And sure enough, the media was all pink, and the cells, he looked down the microscope, were all dead. And then he looked at the plate that had the cells that had the overexpression of BCL2, no growth factor. And he thought, oh gee, it looks a bit of a different colour. So instead of throwing them in the bin, he thought, oh, I'll just have a look. He put them under the microscope, and he saw that they were all growing completely. They hadn't died. And it was at one point that he just realised that BCL2 was a survival factor that made the cells, allowed them to grow without the growth factor. And so it's that one discovery, one moment that had that joy of discovery, that he'd actually realised what BCL2 was doing. And so when he looked 40 days later, you could see that the cells that were overexpressing the BCL2 kept growing while all the control cells died. So that was 25 years ago, and that has now led to the development of mimetics or small molecules that block the function of BCL2. And now there are clinical trials which are in phase 3 clinical trials of these small molecules that inhibit BCL2 in patients like this with follicular lymphoma. And I was speaking to one of the clinical researchers that is running some of these trials, and he says that it's incredible, the response. So it takes a long time. Yes, it's like test cricket, not 2020, but it's those real moments of joy that makes clinicians like me really love laboratory-based research. Because really it's like a clinical trial every day, because you're setting up randomised trials, you've got controls and experimental arms. And so really I think that's the great joy of laboratory-based research. So you could argue that PhD student was lucky. He thought he was a bit stupid. He forgot to add the growth factors, went to the pub. But he was smart in that he didn't just throw the cells away when he got there the next week. He put them under the microscope and had a look to see what was going on. So it requires people with an open mind rather than thinking you know what the answer is. And that's really the critical point. It's sometimes serendipity, but it's often having an open mind to make these sorts of discoveries. So really that's the major thing that drives me and drives many people doing laboratory research, is that real joy or an excitement. It doesn't happen every day, but when it does, it's fantastic. And I think the AMREP precinct has many laboratory-based research projects which give you that opportunity to have those moments of real discovery, discovering things that no one's ever discovered before anywhere, ever. So as far as laboratory research goes, there's many other things. I mean, one of the other things that I think laboratory research really is going to come to the fore is the era of genomics. And really, again, genomics, to try and understand what the genetic mutations are, really requires a laboratory-based understanding of how research is done to understand how genetic mutations cause disease. Doing a laboratory-based honours project will also provide you with some other new skills, particularly in experimental design and specific testing of hypotheses, and obviously is critical for providing a platform for a PhD. I mean, it also provides you some general skills which you'll acquire whether you do clinical or laboratory-based research, particularly with problem solving, organisation of your project and teamwork. And really, as Steve said, one of the major advantages of doing a project here, whether it be clinical or laboratory-based, is that it's tightly linked to the clinic. So even if you're in the laboratory, there is always that understanding of what the relevance of your research is to human disease. So just briefly, this doesn't relate specifically to laboratory medicine or laboratory research, but really when you're thinking about what you should look for, it's really a balance between the passion, if you've got a passion for doing a specific thing, whether it be diabetes or respiratory medicine or blood research, and really a balance between that and finding the best environment. And I think AMREP here is really a fantastic environment which should be able to provide you with a wide opportunity of things. And as Sharon has mentioned, really it's very important that you should have a clear project with aims and questions which are testable and achievable in the time frame. And I'm sure that at AMREP you've got to make sure that there's adequate supervision, and there are plenty of other students. And really, just like that PhD student from 25 years ago, you really do have to have a project which you feel is going to make a difference. It may not make a difference right now, but within the whole context makes a difference ultimately. So they're the sorts of things that I'd advise you to be looking for if you're considering an honours project and hopefully a PhD after that. So I'll leave it at that.
So hi everyone, I don't actually have a higher degree apart from my honours, so I'm kind of like the comedic relief tonight. So but I'm here tonight to talk to you about what to expect from your honours year and the honours experience from a student perspective. So as all the other speakers, so Professor Lewin and Associate Professor Curtis have mentioned, there's a highly collaborative spirit here at the precinct, so even if you choose one particular department or institute, chances are your project is going to overlap into the other departments, areas of expertise, etc. So you're not going to be pigeonholed into one specific niche area. So honours, what to expect? So I googled honours degree and this was one of the top images that returned, which I thought was pretty funny, but I also thought it was rather apt because that's exactly what I'm here to talk to you about. So I wasn't actually going to talk about my personal experience in the lab as such, but I think in light of the previous talks, I should just mention that my project was heavily lab-based, but it was also entirely clinical. So just because you're doing a clinical project does not mean you won't be doing a whole lot of lab work, getting those experiences, but also just because you're in the lab does not mean you won't have a clinical perspective. There's a very clinical environment here at AMREP, so even if you're doing a mouse-based project or something like that, chances are there will be a clinical element to your project. So once again, very flexible. So when I was preparing this talk, I was trying to think of what I should convey to you and what the thing that jumped out to me most about my honours year, which I did a couple of years ago here. And the first thing was, it was not at all what I expected. So you're all in undergrad, maybe a bit further on, but you probably think honours is going to be a really dry year, it's going to be really hard, it's just going to be one of those hard slog years, try and get through it, try and pass at the end, yeah? But in fact, it's actually a lot of fun. It was not at all as dry as I thought, it was really exciting. So as I said, mine was a laboratory-based project, but clinical. And with that comes an experience that you will not get in any other circumstance, pretty much. It's a really full-on year, but it's really dynamic, it's really exciting. So you're going to have your two worlds. So there's the lab and the office. You're not just going to be stuck at a computer 9 to 5, doing really dry, lots of analysis, etc. You've got the lab as well, which is where you get to do all your best work. And also, if you're not feeling it, you're a bit unco one day, then maybe you stay on the computer and stay out of the lab. But it's really flexible, and it's really up to you how you manage that. There's also lots of opportunities that crop up during honours that you won't get anywhere else. So whether it's just learning a new protocol, learning how to use a new machine, or even going on a conference, you'll get a lot of opportunities. My advice to you, if you do go into honours, embrace it. Don't worry if you feel stupid, don't worry if you make a mistake. It's the year for just jumping in and doing things. So honours is an incredibly rewarding year. It's hard, it's challenging, I'm not going to lie to you, but it's really worthwhile. It's one of those things that at the start of the year you know absolutely nothing. You spend most of the first couple of months smiling and nodding and hoping your supervisor doesn't realise that you have no clue what's going on. I mean, there'll be a couple of you that are probably really switched on, but for me it was, I have no idea what I'm doing. But by the end of it, you finish your thesis, you've done your defence, whatever, you look back and you're actually like, I understand now. I can look at other scientists' research and I understand what's going on, and that's really rewarding, seeing that growth that you get not only as a scientist, but also just as a personal and professional person. I also just wanted to note that honours is a platform not just for going into PhD and academia. That's really an ideal situation because you get to apply all the skills you've learned during your honours. But you can also go on into med, you can also go into teaching, you can do really whatever you like. Honours looks great on a resume, so if you don't know what you want to do, honours is definitely worth considering. So I just thought I'd finish up, because my talk's just a bit quick. If the academic side and the workload doesn't sound really exciting, are real reasons why you should actually do honours. So first, as a scientist, you can dress however you like, as long as you are PC2, so closed shoes, hair back, you can really do whatever you like. Become a redhead, whatever you like. Flexible working hours. I think a lot of the prospective supervisors are probably cringing at that a little bit, but once you're independent in the lab, if you get the work done, you can do it whenever you like. So that makes other life events really easy to work around. The pinnacle of all students, free food. So it's a big precinct, lots of different institutes. Chances are, a lot of days you'll have seminars or morning teas and you'll be able to pilfer something. High-speed internet, used for good, not evil. And finally, scientists are a really nerdy bunch of people, so perhaps you haven't been around many nerdy jokes, but by the end of your year, you'll have a completely different sense of humour, and you'll find things funny that people just don't understand. It's a little niche group. So good luck. I'll be floating around and so will a lot of other PhD students, so if you have any questions, feel free to come have a talk.
Okay, thanks for that, Jodie. So, that's me. I'm Mark Wright. How do I operate this thing? Okay, so I'm the Honours Coordinator for the Central Clinical School here at AMRAC. And so I'm going to tell you what to do today and how to apply for honours. And so, your task today is to check out your project booklet, think about areas of research that interest you, and use today to go and talk to as many people as you can. So consider today like speed dating, okay? You've got your, they've given you their resume of what they're interested in, you know what you're interested in, go and check them out. And they'll be checking you out as well, okay? So if you want to do well in honours, a good relationship with your supervisor is critically important. You have to get on with them intellectually, you have to get on with them socially. Okay? And so your task is to really do your homework. Do your homework on your supervisor. Check them out. Read their papers. Don't just think that because they were nice today, they'll be fine. What you need to do is email them, go and speak to them, ask if you can meet their students, and really be diligent, because this is a really important year in your career. So I want you as Honours Coordinator to make an informed choice. Okay? Now, it's very important to consider more than one supervisor. You might have your heart set on one project, and that's utterly fine. But, unfortunate things can happen in science, like someone's fantastic grant didn't get renewed, or a key member of staff goes on maternity leave or gets another job. So things can fall through the cracks. And also, some labs it's very competitive to get into. And so, you might be very good, but the other student who applied is averaging 98 and you get out-competed. Okay, so you need a second preference. So definitely don't put all your eggs in one basket. Definitely check out several labs and have 2 or 3 preferences. And I should say that when you come to fill out your paperwork for both the BMS and BSc students, you need to list 2 preferences. And certainly for the BMS applications, you need to get signatures from 2 separate projects. And I urge you to get signatures from 2 different supervisors, just in case something untoward happens, okay? So, how do you actually get in? Well, there's no short answer because it varies depending on your degree, and what you need to get in if you're a BMS student is slightly different from a BSc student. But the take-home message is you need to average around about 70% in 4 relevant subjects is the benchmark, and I'm happy to discuss that in more detail. Now, if you're coming from another university, those requirements might be slightly different. Okay, so here are some websites where you can download forms. So the BMS application form just arrived in my inbox today, so we should have it up on the website very shortly. But what you want to do, having checked out your lab, having talked to lots of people, once you've made a choice, you need to fill out your paperwork. So download the relevant forms. Here's the Central Clinical School website here. You will need the signatures of your potential supervisors, and you will need my signature if you're a BMS or BSc student, okay? And if you're wanting to do honours in the Central Clinical School, if you're more interested in a project in public health and preventative medicine, then Jay is the person that you need to contact for her signature, okay? Then having done your paperwork, you submit your application to the relevant faculty office, be it medicine or science. Now, I can tell you with certainty now that the deadline for the BMS applications is November the 15th. It's probably the same for BSc. If you're from another university, the deadline tends to be at the end of November, 2 weeks after the Monash deadline. That's not quite out yet. Okay? Now, you also have the opportunity to apply for scholarships. So I understand that there are 2 scholarships available at AMREC for honours students. $6,000, it's better than a poke in the eye with a sharp stick. Okay? And so these are very competitive, but I can guarantee you that you're not going to get it if you don't apply. Okay? So do put in your application, and there are also scholarships available centrally through Monash that you should also check out. Okay?